Okay, so isosceles triangle trivia. Dun, 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 dun. And you can see we have some patterns that involve lots and lots and lots of isosceles triangles. So we want to talk about isosceles and see there's many applications of the properties of an isosceles triangle. Now this is a picture of an isosceles triangle. There are two key facts that we have going on here. The first key fact is that two sides are equal. We've talked about that a lot, and that's what these hash marks here mean. These two sides are called legs. Here's the new one. Two angles are also equal. If the two legs are equal, two angles are equal. It's the angles that are across from the legs. These are called the base angles. So we call the legs the sides of the triangle that are equal. Obviously the piece on the bottom we call the base. And the base angles are also equal. So basically, it's the angles that are across from the legs. So if the legs are equal, which they are in an isosceles triangle, then the angles across from it are equal. That angle up at the top, that's commonly referred to as a vertex angle. So let's start applying some of these ideas. Find the value of x. What did we say the three angles of a triangle add up to? We said that they add up to 180 degrees. So therefore, if I take the x that's in the bottom on the left and the x that's in the bottom on the right, how do I know they're both x's? Because they're the base angles of an isosceles triangle, and we know they're congruent. So if I add up all three angles, the first x, the second x, and the 84, I get 180. Combine my terms, same side, same operation. 2x plus 84 is 180. Subtracting the 84, 2x is 96. And I get x is 48. Nice, simple application of the idea that the base angles have to be equal. In other words, if we give you one, you know the other. Okay, find x here. Go ahead, using stop and start. Okay. So since the angle on the left is 110, that base angle on the left, the base angle on the right is, oh, I'm sorry, I shouldn't have said 110, x plus 10. The angle on the right is also x plus 10. So if I want to find x, I add the vertex angle at the top, which is the 3x, and then I add the base angle of x plus 10 and the other base angle of x plus 10, and I get 180 degrees. So that's 5x plus 20, getting all my x's together and all my numbers together. Minusing the 20, I get 5x is 160, dividing by 5, and I get x is 32. It asked me to find x, so I could stop there, but I could also say that the vertex angle is going to be 3 times 32 or 96, and the base angles are each going to be 42, because they are x, which is 32, plus 10. Okay, let's try out the next one. Find the length of a leg of this particular isosceles triangle. Remember, the legs are equal. Okay, so 3x plus 5 is going to equal 5x plus 1. This is an opposite side, opposite operation situation. Subtracting the 3x, 5 equals 2x plus 1. Subtracting the 1, 4 equals 2x. Dividing by 2, x is equal to 2. Okay. What's the length of a leg? 3 times 2 plus 5 is 6 plus 5, which is 11. And just to show you that they're equal, the other one's 5 times 2, which is 10, plus 1 is 11. So in both cases, the legs are the same, 11. Okay, in this one, find the value of the question mark. Notice there are multiple isosceles triangles there. Okay, so this angle up top here is 116 degrees, but it forms a linear pair with this angle underneath it here. So together they add up to 180, which makes the missing angle 64. But hey, wait a minute, that's an isosceles triangle. So that's, I know it's up high, but that is a base angle because the base angles are the ones that are across from the equal sides. So that means this angle here at A is also 64. Now let me just emphasize, if you watch my cursor here are the equal sides. The base angles are always across from the equal sides. So as the two legs are equal, the sides that are equal are called legs. The base angles, which are the angles across from the legs, are also always equal. Now, what do the three angles of a triangle add up to? 180 degrees. So 64 and 64 adds up to 128, which means the missing angle here is 52. But 52 is vertical to the angle in the other triangle, which is 52. And here's your legs with the double hash marks. So just as this is 52, the angle at D is also 52. Again, same thing, base angles being located across from the congruent legs of an isosceles triangle. 52 and 52 add up to 104. The value of the vertex angle, which is where the question mark is 180 minus 104, which is 76 degrees. Okay? One of the really cool things about an online course is if you didn't understand that, just use the slider to scroll back to where this problem began, and you can go through that again. It might take 2 or 3 opportunities of reviewing it before it makes sense to everybody. Okay, next question up. Find X and Y. Okay, so in the case of X, that is an isosceles, it's more than an isosceles triangle, it's an equilateral triangle where all 3 sides are the same. So equilateral triangle is also known as an equiangular triangle. We know that, we studied it. So 180 divided by 3, because all 3 angles are equal, means each angle is 60 degrees. Now, what's the missing angle inside the triangle? Right over here. Well, here's a linear pair, 60 and this angle CBD. That angle is going to be 120, because 60 plus 120 adds up to 180. And now, if I do 120 plus 35, I get 155. Working just in this triangle on the right, we know those 3 angles add up to 180. So 180 minus the 155 gives me 25 degrees. So the angle at D is 25 degrees. Okay. Now let's analyze the lengths of the sides of the triangle compared to the angles. Okay. Let's kind of look this over a little bit. The 3 sides were equal, so all 3 angles were equal. Notice that in this equilateral triangle on the left here, triangle ABC. All 3 sides were equal, all 3 angles were equal. Interesting. If the sides are equal, then the angles are equal. Well, what if the sides are not equal? Well, what we notice there is that the bigger the angle, the longer the side. So the longest side of triangle BCD is the side that's across from the 120, okay? And the smallest side is the side that's across from the smallest angle, the angle of 25. So the bigger the angle, the longer the side across from the angle. With that in mind, what's the longest side or the biggest angle of each triangle? So in the first problem, I give you all the sides, and I just want you to tell me the biggest angle. In the second problem, I give you all the angles. I want you to tell me the biggest side or the longest side. Go ahead. Okay, so while I am going over this, my dog is chewing a bone in the background. So that's the noise you hear every now and then. In the first triangle on the left, the longest side is BC. The angle that's across from BC is A. So A is the longest angle. The largest, I should say the largest angle. If we take a look at the diagram of the triangle on the right, the biggest angle is B. So the side across from B is AC. And we would say AC is the longest side. Okay, so once again, remember that the longest side is always opposite the biggest angle, and the biggest angle is always opposite the longest side. Same is true for the smallest angle. Smallest angle is opposite the smallest side, and the smallest side is opposite the smallest angle, which we're going to do right now. Go ahead. Okay, so in the first triangle on the left, triangle PQR, as we look at that, we see right away that the smallest side is 17. So therefore, the smallest angle is angle R. as we take a look at on the right, we say, okay, well, the smallest angle there is 37, so the shortest side will be BC. Now, sometimes you might look at these and say, well, I think I can tell by looking, but I wouldn't do it that way. I would make sure that I figure out the angles or the sides and then always look across from it, okay? Another way you'll see this concept generated is they'll say order the angles from greatest to least, or they might say from least to greatest, but they're going to ask you to put them in order, either ascending order or descending order. In this case, we want to go descending. We want to start with the greatest and work our way down to the smallest. Go ahead. Okay. This is angle Q, then angle P, then angle R. The longest side is 9.1. The angle that's across from 9.1 is angle Q. The next longest side is 8.8, and the angle that's across from that is angle P. And the smallest side is 7.5, and the angle across from that is angle R. So it goes angle Q, angle P, angle R. All right. So that is a summary of an inequality regarding the lengths and the angles of a particular triangle. Okay, we're good.